When you think about modern medicine, what comes to mind? Probably brilliant scientists, right? Maybe some super complex machines. But what if I told you one of the most crucial pieces is something we almost never see? Today, we're diving into the story of an unsung hero, something so basic yet so important that medicine as we know it would literally fall apart without it. So let's just jump right in with a pretty serious question. What do you think is the biggest #1 threat to making the life-saving medicines we all count on? And no, it's not a new superbug or a lack of funding. The real enemy is something so small you can't even see it. Okay, so check this out. It's a tube, a simple coil of clear tubing. Kind of boring, right? Looks like something you'd find at a hardware store. But believe it or not, the answer to that huge question is sitting right here. The biggest threat is contamination. And this humble-looking tube, it's our best and maybe our only line of defense against it. You know, to really get why our hero is so important, we have to understand the villain it's up against. We're talking about a full-blown contamination crisis. It's a war being fought every single day in pharmaceutical plants, but it's on a scale that's totally invisible to the naked eye. And the scale of this problem, it's absolutely staggering. Seriously, we're not just talking about a little speck of dust. A single stray particle, one, can ruin an entire batch of medicine, and these batches can be worth millions and millions of dollars. When that happens, it's not just money down the drain. It means shortages of critical drugs. It means treatments get delayed. So what are these invisible enemies exactly? Well, they're things that are all around us, all the time. You've got environmental debris, microscopic dust floating in the air, even tiny biological things like bacteria. Out here in our world, they're no big deal. But you get them inside a drug manufacturing facility, they become an absolute catastrophe. Which brings us back to our solution. Our unlikely hero in this fight. It's time to give a proper introduction to the high-purity silicone tube. Now, to really appreciate what this tube does, you have to picture something called the fluid path. It's a great name for it. Think of it like the veins and arteries of a drug factory. It's this whole network of tubes where the raw ingredients get mixed, processed, and eventually turned into the medicine we need. And that entire system, from start to finish, has to be, well, perfect. Absolutely 100% pure. You know, the source material we looked at for this really nails it. It says this tubing isn't just some secondary component. It's not just plumbing. It is a critical element. It's what ensures the safety, the purity, and the efficiency of the whole process. It's basically the gatekeeper standing between a pure medicine and a contaminated one. So where does a hero like this get its powers? It's a great question, and it's not just what it's made of, it's where it's made. The origin story for this tube begins in one of the most pristine, cleanest environments you can possibly imagine. It really comes down to a 3-step path to purity. First, you've got to start with the absolute best stuff. Ultra-pure, medical-grade silicone that's cured with platinum. No shortcuts. Second, the tube itself is actually formed or extruded inside a certified clean room. This is a super sterile place where those invisible enemies we mentioned just can't survive. And finally, once it's made, it goes through some seriously tough testing to make sure it's perfectly smooth on the inside and has absolutely 0 stray particles. 0. And all that work, that incredibly careful process, gives this silicone tubing a whole set of unique abilities. Let's just call them what they are: superpowers. And these are what make it so essential in this fight for purity. Okay, superpower number 1. The challenge is chemical contamination. See, some materials can actually leach or kind of shed their own chemicals into whatever liquid is flowing through them. Big problem, right? But this silicone's superpower is that it's non-reactive. It's totally inert. It doesn't add anything to the mix, so you can be sure that the only thing in the medicine is the medicine. All right, next up, extreme heat. To make sure everything stays sterile, this equipment gets blasted with crazy high temperatures. I mean, hot enough to make most materials just melt or warp completely, but not our hero. Its superpower is thermal stability. It just takes the heat, holds its shape, keeps its strength, time and time again. And the list of heroic traits just keeps going. It's super durable, so it won't wear down from constant use. It's also see-through, which is huge because it lets people literally watch the fluid flow and catch any problems right away. And that super smooth inside surface, it makes it impossible for nasty stuff like biofilm to grab on and start growing. Okay, so we've seen its origin story and we know its superpowers. Now let's go find out where our hero is on the front lines, fighting the good fight out in the real world.
And you'll find it right in the guts of the most critical pieces of medical equipment out there. It's in peristaltic pumps, which are these amazing devices that move liquids with insane precision. It's in bioreactors, where actual living cells are grown for brand new therapies. And it's in the aseptic filling lines. That's the final, super sterile step right before a vaccine or medicine gets put into a vial. Now, it's really important to know that not all tubes are created equal, not by a long shot. Choosing the right one is a whole science. Engineers have these detailed checklists, and they look at everything. The grade of the material to make sure it's safe, the exact dimensions down to the micrometer to guarantee it fits perfectly with no leaks. I mean, every single detail matters when you're talking about someone's health.
So this tech is already pretty amazing, right? But it is not standing still. The quest for perfect purity is always moving forward, and that means our hero has to keep evolving too. I mean, think about it. We've gone from just basic rubber hoses in the past to this incredible clean room-made tubing we have today. But the future sounds like something out of science fiction. We're talking about smart tubing. Tubing with tiny sensors built right into the walls that can track things like pressure and flow in real time. How cool is that? And the innovation isn't stopping there. People are also working on making the whole process more sustainable and even creating custom-engineered tubes for really specific, tricky jobs in drug production. So yeah, the next time you hear about some amazing new medical breakthrough, take a second to remember the silent guardian that helped make it happen. This little tube is the thing that makes sure the medicine we all rely on is safe, pure, and actually works. It really makes you think, doesn't it? What other invisible technologies are out there quietly holding our modern world together?